Hi, my name is Julia. I'm an AI researcher at Circle. Today I would like to talk about explainable AI, what it is, and why we need it. For a long time, the only thing researchers and machine learning engineers cared about was whether or not the machine is able to produce a certain result. We focused on how to make machines think like humans, act like humans, and help us perform daily tasks. For example, can we make an AI play chess, or drive a car, or give medical diagnosis? As the systems got more and more complicated, they were analyzing billions of parameters at a time. Sometimes such artificial intelligence systems would be even more successful than humans at a certain task. For example, robotic arms that perform extremely hard heart surgeries have a higher precision than some of the most experienced doctors. But once we started achieving these great results, another problem arose. The question was, how did the machine get there? As you probably know, the most widely used algorithm for building AI is neural networks. They can work with billions of parameters at a time, which makes them so important in modern industry and science. However, these advantages come at a cost. Neural networks work like black boxes. They receive an input, perform certain operations on it using filters, and then give an output. We can't track down what exactly happened inside the black box, and that's what makes using them problematic in certain areas. Because if we don't know based on what the machine made its conclusions, how can we trust it? This is why computer scientists started to think about that maybe it's time to concentrate not only like how to make AI work great, but also how to make it explainable, so that the result it provides are more trustworthy. What is explainable artificial intelligence? Explainable AI is a set of methods that make it possible for humans to unpack the black box of computer decision making. Explainable AI can belong to any of the following categories. Those that are inherently explainable, they have been designed in order to be easy to understand. Black box models, they were not designed with the principles of explainable AI in mind, so special techniques are needed to decipher its meaning. Replicable models. If the research results achieved with the machine learning model can be replicated, it means it works and we understand how it works. However, sometimes it can be difficult to trace down exactly whether the replication has been correctly made or not. Explainable AI kits are often provided by leading tech companies like Amazon and IBM. They help to describe the AI model performance, its expected outcome, and potential biases that can impact the performance. Today, no company that uses AI can go without integrating the principles of explainable AI into its design. If they fail to provide accounts for their model's decision, they can face million-dollar lawsuits like it happened with Google and Facebook. Overall, explainable AI helps to promote accuracy, fairness, and transparency in the organization. It helps you to adopt a responsible approach to designing AI systems. When we talk about explainable AI, it's important to distinguish between explainability and interpretability. These terms are often used interchangeably, but it's not correct. It might seem they mean the same thing, but in fact they mean two different things. So if AI is explainable, it means that its internal decision-making is comprehensible for us humans. In a perfect world, we would just make a query in English to the machine asking why did it do that, and it would provide a clear list of factors that impacted its decision. If AI is interpretable, then we can predict the output given the input. If you have good interpretability, you can predict the results the model will give you, but not why it does it. So the internal decision-making will still remain a black box. Both are important. Interpretability allows us to see what exactly is the model learning, but to understand what goes wrong if it does, for that you need explainability. So, what are the main principles of explainable AI? Explainable artificial intelligence is based on four main principles. They have been formulated by the USA National Institute of Standards and Technology. So, they go as follows. AI systems should provide explanations that are backed up by evidence. Explanations should be meaningful in a way that can be understood by users of a software system. Explanations should be accurate if describing the artificial intelligence system's process, and machine learning and deep learning models should operate within the limits that they were designed for. Now let us talk about each of these principles in more detail. Explanation. AI is expected to provide an explanation for its outputs and also give evidence that supports the explanation. The type of explanation may vary depending on the system, but as a minimum, it should be there. NIST outlines several categories, for example, explanations that benefit users by making them more informed. This applies to patients in healthcare systems, loan applicants in banks, and etc. XI provides reasons for why this or that diagnosis was given, or why this or that loan was approved or not. Another kind of explanation is expected to help systems gain trust and acceptance in society. For example, Facebook often faces negativity for not disclosing how its feed algorithm works. If they provided explanations that help users understand why this or that post appears in their feed, it would help Facebook to improve its public image. Meaningfulness. The principle of meaningfulness is important because the user must understand the explanations provided by the AI. However, this principle is hard to achieve because the users may differ in their background and level of understanding. Ideally, the explanations should be accessible to anyone, regardless of their knowledge and skill. A way to check whether the explanation given by artificial intelligence is truly meaningful is whether it gives enough information so that the user could complete a task. Accuracy. Explanations that AI gives to its output should match reality. It is the responsibility of AI engineers to make sure that AI clearly describes how to arrive at certain conclusions. Accuracy doesn't apply to the result, but only to the explanations. If they come from erroneous premises, then the users can't really benefit from them or trust them. Limits. Every system has knowledge limits, stuff that it doesn't know. AI should be aware of its own knowledge limits and declare them to the user. Now, as I've mentioned before, the industry is having a shift towards more responsible, more explainable models. Businesses don't just want solutions that work, they want to understand whether they can be trusted. Business stakeholders prefer models that are interpretable since they are intuitively easy to understand and validate, like linear regressions and trees. Moreover, businesses care about being trusted by their non-tech audience, and improved interpretability can help with trust too. However, linear models can be compared in effectiveness to more advanced models, such as neural networks, that are great, but naturally almost completely unexplainable. In a perfect world, we would strive to have both high accuracy and high explainability. But in the real world, if we want to avoid bias, fix errors, and in general trust neural networks, then we sometimes have to sacrifice accuracy towards explainability. There are various techniques that help with achieving explainability. Local interpretable model-agnostic explanations, or LIME, helps you understand why your model makes certain predictions. To do that, LIME uses input data and creates a series of artificial data containing only a part of the original attributes. For example, if the input data was a text, it creates different versions of the text, randomly removing some words. It tries to classify the data to different categories, and depending on whether certain keywords were present or not, we can see if they're important for the prediction. LIME can also be used with images or tabular data. Another popular technique is called Shapley Additive Explanations, or SHAP. SHAP helps to explain the predictions by machine learning models by assessing the contributions made by each feature to the prediction and selecting the most important ones. Based on Shapley values from game theory, this theory operates with coalitions, groups of values, and helps to estimate exactly how much every value in a coalition contributed to the final result. In order to do that, we need to remove one member of the coalition and look at the respective values of the two coalitions, compare the difference between the two. This difference will be the marginal contribution of the particular value. The same is done for the rest of the values. A similar principle is used in SHAP to estimate the importance of a particular feature. Other popular explainability frameworks are Explain like I'm 5 and Skater. Now you know what Explainable AI is and how it works. Thank you for watching. Don't forget to subscribe.